All right, let's go ahead and get into chapter 13. All right, so we're in chapter 13. With some of the things we're going to talk about today is volume and mass. Okay, we're going to talk about different shapes, finding the volume. Also, a little bit of metric conversion, not very much English measurement, just a little FYI kind of stuff for you. And then some ratios of volumes and measures of mass. Okay, so we're talking about quite a bit of stuff here. So volume is how much is inside the figure, okay, the amount inside. Okay, it says what is the volume of each figure. So we assume that each of these little blocks are 1 by 1 by 1s, which means to find the volume of this figure, you just count on how many blocks there are. Now don't forget about the ones underneath. Okay, so you count all those, you're going to end up with 9 cubes. Okay, the 9 cubes, so it's 9 cubic units. Now in the surface area, you're going to count sides. Now in this, they are under the assumption that every side, including bottoms, count. So if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 34, I think that's right. Okay, kind of do it kind of quick. And you should have 34. There we go. Okay, so you're counting the bottoms also. Now, how does it change if I move this block over 1? Well, you're going to add 2, 1 more here and 1 more here. Okay, so you end up with 36. Okay, so it does change as I move it. Okay, but the volume on both of these would still be 9. The volume doesn't change. The number of faces showing, that's your surface area, does change. Okay, so those are things we look for. All right, so volume of a few things. Okay, rectangular prisms. Okay, in a rectangular prisms, we're talking about the height times the width times the length. And for some reason, this computer always does this, but this would be L. Well, it doesn't like the L when it does that. I need to fix that. Okay, so that's L. So it's all 3 spots multiplied together. All right, now converting a few things. So decameters, these are decameters. Okay, the only reason I know is DM, decameters. Actually, decimeter, excuse me, that's a centimeter there, so that should make this a decimeter. So this is 1 decimeter cubed, okay? Well, if there are 10 centimeters in a decimeter, that's 10 going this way, 10 going this way, 10 going up, that would be 1,000 centimeters squared, okay? Well, on the rung of deci, you have meter, deci, and then centi, right? So if I go from deci to center going down to a smaller, you're going to move it to the right, your decimal to the right. Well, one place linear is 1 decimal place, but in volume, it's cubed. So instead of 1 going down, every 1 space you go down, you actually go down 3. So you move the decimal over 3 places, and I get 1,000. Okay, remember, if I'm going smaller unit, I'm going to the right with my decimal. Bigger unit, I'm going to the left with my decimal. Okay. Same thing here. Meters to centimeters, I'm going smaller. Okay, so if I'm going smaller, we're moving to the right. Well, there's 100 centimeters. Okay, so that's 2 places down. So for every side, that's 2 more places. So 2, 4, 6, you're moving 6 places over from the 1, so that gives you 1,000,000 centimeters squared cubed. Okay, And then deci to a meter, you're going up, which means I'm going to the other direction. And deci to meter is one place. So if I move it one place to the left on linear, and then 3 places on cube, so it's 3 different times, one place. So that's why you get 0.001. All right, so let's look at converting then. Let's see if we can do this. Meters to centimeters. Well, that's 2 places. Well, for cubic, for volume, it's not just going to be 2 places, it's going to be 2 places 3 times. So if I start with a 5, you're going to go 1, 2, 3, 4, 5, 6. All right. And then from millimeters to centimeters, you're going the opposite direction. And it's 1 place, so it's a grand total of 3. 1, 2, 3. Well, let's see how we did. There we go. 12.3. And then 1, 2, 3, 4, 5, 6, 5 million. All right, good job. Good job, everybody. Give yourself a pat on the back. All right, so liters, okay? When we talk about volume, sometimes we talk about liters, dealing with water, how it fills up, okay? So 1 liter would be the same as 1,000 centimeters cubed, okay? So it ends up being the same amount, okay? So they designated a liter of water would fit into a volume of a cube that's 10 centimeters wide. All right, so 10 by 10 by 10 is 1,000 centimeters cubed. Okay, so that is just a standard move over. All right, so if we talk about, if we have everything in terms of liters though, liter is considered volume. So every metric label prefix is the same. Okay, so 1 liter, okay, a kiloliter would be 1,000. 3 decimal places. 1, 2, 3 up. Move it to the right. 3 to make it 1 kiloliter. So liters down to milliliters. 1 liter would be, if I go down, a milliliter is 0.001, so it's 3 decimal places. So remember, if I was going from liters to milliliters, I would move it to the right. If I go from liters to kiloliters, I move it to the left if I'm converting. Okay, so liters to milliliters, that's converting. We're going from big to little, we're going to the right. How many places? 3. 1, 2, 3. Okay, I'm going from milliliters to liters. That's still 3 places, but it's going to the left. It's small to big. Okay, let's see how we did. There we go, 3 decimal places and 3 decimal places. Again, good job, everybody. All right. So some basic things, basic units of volumes, we can have cubic inches, cubic feet, cubic yards, okay? Some conversion things, if you were ever asked, is 1 gallon is 231 inches cubed, or a quart is 1/4 of a gallon. Well, that's the one you need to know, but I'm not gonna make you do any of this stuff in my class. Now, you should be able to go cubic yards. Now, here's the thing. If I'm going cubic yards to cubic feet, there are 3 feet in a yard. Well, a cubic yard would be a yard by a yard by a yard, which would be 3 feet by 3 feet by 3 feet, which would be 9 feet. All right. So what you would have to do is take, or not 9 feet, 3 by times 3 by times 3 is 27. So you would take the 45 cubic yards and multiply by 27 feet cubed and get 1,215 feet cubed. If I went from inches to yards, well, there's 36 inches in a yard. So that's 36 by 36 by 36, which happens to be 1 over 36. and you have to move it over. Again, I'm not going to make you do that kind of conversion. All right, finding volume. Figures. Cube, length times width times height. 6 times 6 times 6 is 216. Prism, 3, rectangular prism, 3 times 10 is 30. 30 times 15 is 450. Now, cylinder is very similar, but you take the area of the base, which is a circle, pi r squared times the height. Well, r squared is 25. 25 times 10 is 250. 250 times pi is 250 pi centimeters cubed in terms of pi. Okay? All right, now, how do I deal with volumes of pyramids and cones? Well, if you look at a prism compared to a cone, the volume is essentially, as long as it's a right pyramid, is a third of the prism. So you would find the volume of a pyramid, which is usually pretty easy. Find the area of the base times the height, and times by a third, or divide by 3, however you want to look at it. Okay? Cones the same way. Cones very similar to a cylinder, pi r squared times h, but it's going to be a third of that. So you would find the cylinder, pi r squared h r pi r squared, and divide by 3. Okay? All right, so if you take these and you wanted to find these, pyramid, so remember, is the area of the base, 16 times the height, all divided by 3. Same thing here. Radius squared, 36 pi times 10 divided by 3. Now 3 goes in 36, 12. 12 times 10 is 120, 120 pi. Okay, this one does not go in nice and pretty, unfortunately. But you probably have a fraction, 80 over 3. And this one, 96 pi. Okay. Oh, my bad. I told you wrong on this one. I rushed. Okay, let's fix this. Okay, so why is this answer this? Okay, because I'm not using the 10. Okay, I still use the 36 pi, but that's not the height. I have to find the height. This is L. My bad. Can't give myself a hand this time. Okay, I have to find this. So you would use Pythagorean theorem. 6 squared plus h squared is equal to 10 squared. That's 100 minus 36 is 64. This is 8. So you put the 8 in here. That's where you get the 96 from. So you got to be careful. They get a little tricky sometimes. They got me that time. I got to stop rushing, right? All right. So here's a pyramid. Okay, find the volume of the pyramid representing the net shown. Well, again, you would find the area of the square, which is 10 squared. Okay. Now, how do you find the height of the pyramid? Okay. Well, the height of the pyramid, okay, this is 10. Okay, these are equilateral. Okay, so you have to find the height. Okay, this is going to be 5 and 5. Okay, 5 and 5, and you'd have to do go figure it out through all the other work. So let's work on that. Okay, so if I bend this up, I got to find the height of the pyramid, not the slant height. Okay, but I probably need the slant height. That's a 5, and these are equilateral. Now, how does that equilateral? That means this is 60 right here. So this is a 30, 60, 90. Okay, which means if this is 5, that's short side. This is hypotenuse. This would be 5 root 3. Okay, now that's the slant height. As I bend it up, I'd have 5 and the slant height, so I would have this now. Here's 5, and here's the slant height, 5 root 3. I would need the height. This would be my height of my pyramid. Okay, so you'd have to do Pythagorean theorem to find this, and this would still be your right angle. There's my hypotenuse, and you'd have to find that distance there. Okay, which would be, let's see, if I square this, that's 25 times 5, that's 75. Okay, this is 25 minus 25, which would be 50, and take the square root of 50, and that's what that is right there. And you'd find it, okay? A little bit more tricky. You'd almost have to build it yourself. All right, volume of a sphere, okay? Formula is very simple. 4/3 times pi r squared, okay? Okay, so pi r squared. So you would get 6. Yeah, I knew that was wrong. That is I thought something was weird. That is a major typo. That's a typo right there. Okay, that's supposed to be, I thought that was weird because I'm talking about volume, and volume in my head is cubed. This is supposed to be cubed. Bad typo. I didn't make this. All right, so it's supposed to be 4/3 pi r cubed. Okay, so when I figure this out, basically what I would do is they do 4/3 pi 6 cubed, and you get 288 pi. Okay, you can do it one other way if you wanted to. You can do 4 pi 6 cubed all over 3. Either way, you come up with this. And volume's always cubed, and that was why I knew that. And that's why I hesitated. I'm like, that's not supposed to be squared. Okay, and so that's why. Okay, you're usually going to get, not everything's cubed, but that one has to be, because that was the only variable. Okay, if you go back, show you something here, why I knew that had to be wrong. If you go back to these formulas, notice there's r squared and h. That gives you 3 variables, basically, cubed. Okay, length times width times height. That's 3 variables, cubed. Okay, and that's kind of why I kind of knew that had to be a typo. All right, now, we've done this before. When I figure out the ratios using scale factor, if I have a linear measurement, like length, width, height, perimeter, diagonal, diameter, slant height, these are all linear. Their scale factors are k. Once you know that scale factor of k, anything dealing with areas would have a scale factor of k squared, along with polygons. Okay, so if the scale factor of two things in their perimeter is 4, then in their areas, their scale factors, you find one area, then its scale factor will be squared of that, the other one. The scale factor has to be squared, and that's what we did before. When it comes to volume, okay, the scale factor of areas or surface areas is k squared, but the ratio of volumes is going to be k cubed. Okay, so if you know the scale factor is 2, and the volumes of those shapes, the scale factors will be 8. Okay, how does a surface area of a sphere 10 inches in diameter compare to the surface area of a sphere 5 inches in diameter? The two spheres are similar, So if one is 10, the other one is 5, it has a scale factor of 2. Then their surface areas would have a scale factor of 4. So the 10-inch sphere would be 4 times the surface area of the 5-inch. Now if we take that sphere and we talk about its volume, well, it's going to be 3 cubed instead, or 2 cubed instead of 2 squared. So we're talking about 2 cubed, which is now 8. So the volume of the 10-inch sphere will be 8 times as much. Okay, the radius is 2 times, or it is 2 times as much. The areas are 4 times as much, and the volumes are the 8 times as much. All right, so let's talk about mass. Mass, the definition is a quantity of matter. Okay, so you have so much mass. Its weight is that matter using gravity. And gram is the fundamental unit of mass in the metric system. Okay, so gram is a basic unit. So all of their prefixes work the same way. Okay, so going down decimals by 10, right? Same as it was before. All right, so how do I convert from grams to kilograms? Well, small to big, that means your decimal goes to the left, and grams to kilograms is 3 decimal places. 1, 2, 3. Kilograms to grams, I believe that's supposed to be, should be 3 decimals to the, or is that ton? Are they telling me ton? Let's see here. Nope, that's supposed to be gram. Well, that's tons. Let's go back. Oh, the metric ton. Huh, I didn't see the metric ton on that one. So that's 1,000. So that's 6 decimal places for the grams. Okay. From tons to kilograms is 4 decimal places. So 3 more decimal places, 3 decimal places. So between these two are 3 decimal places. That's what it was. They did a little t, so it confused me. That should be a big T. But that's why 3 decimal places over. Kilograms to metric ton is 3 decimal places. All right, that's special for grams. Okay. All right, so let's look at that one. I'm not too worried about. The waterbed measures 180 centimeters by 210 centimeters by 20 centimeters. Approximately how many liters of water can it hold? Okay, so if you multiply all those together, you're going to get this many centimeters cubed. Now remember, there is a centimeters cubed. There's 1,000 centimeter cubes in a liter, so that would be 3 decimal places, or milliliters to that. Okay, and then the mass of kilograms when it is full with water, that you do not have to know. Okay, I'm not going to be that picky with those. All right, so that is the end of that section.